Today we're going to go through linear inequalities. We're going to see how to represent them on a number line and see how to solve them. We can show inequalities on a number line. This can help us visualize the inequality. In this first question, x must be greater than 3, so we show it with a hollow circle and an arrow pointing to the right, which is all the real numbers that x can be. With this question, the less than has a line under it, meaning that x can be 5. So we show this with a filled in dot at 5 and an arrow pointing to the left because it's x is less than or equal to 5. Let's have a go at these questions. We can solve inequalities much in the same way as we solve equations. There are a few exceptions we'll get to. So with this question, we're going to add 5x to both sides, add 35 to both sides, divide by 5. Now we've got to be really careful here because when we move the x on the left hand side, which we normally want to have with equations and inequalities, we've got to flip that sign. So instead of less than, it will be greater than. And we can show this in set notation, which is shown here. This basically means the set of all values of x for which x is greater than 10. For this question, let's start by solving the first inequality. So we're going to subtract 16 from both sides and subtract x from both sides, then obviously divide by 5. And let's look at our inequality on the number line. So we're going to write out a number line. It can be equal to 3, so it's going to be a filled in dot, and it's less than, so the arrows go to the left. Let's do the same with the second inequality. So we're going to add the 3 to both sides, then divide by 5. And on the number line, we need to have a hollow dot at -2 because it can't equal -2, and then arrow going to the right. We can write this as a single inequality with the -2 and the 3. Now if you look at it, it can't be -2, so x must be greater than -2, but it can equal that 3. And we can also write this in set notation with the curly brackets shown here. In this question, we're going to look at the left-hand inequality first. Now, this looks really complicated, but all we need to do is expand the brackets and then just collect the like terms. Also add the -15 and the 4, and then we're going to add the 11 to both sides, take away the 7x from both sides. Now, we're left with a -x here. Now, for equations, we will just multiply both sides by -1, and we can do the same here, but you must remember that if you ever multiply or divide by a negative, you must flip that inequality. So we're going to times both sides by -1 here, but the greater than sign turns into a less than sign. We're going to do the same with the right hand side, so we're going to expand the brackets, add the 10 to both sides, divide by 5, and we're left with x is greater than or equal to 5. Let's put this on our number line, and we've got x is less than 3, so a hollow dot at 3, and a filled in dot at 5 because it's x is greater than or equal to 5. Now we've got a bit of a problem here because we can't write this as a single inequality, so it has to be 2. It has to be x is less than 3 and x is greater than or equal to 5. So for our set notation, we need to use our union, which is an OR symbol. And OR means OR and in set notation. But if you remember from Venn diagrams, the U is OR, and then the upside down U, or the A looking one, is and this is an OR because x can be less than 3 or x can be greater than or equal to 5. And so in set notation, this is how we do it. We're just linking two of the sets together with that OR sign. Let's finish with this. George says that for x is greater than 4, the lowest value for x is 5. Comment on whether George is correct. If you know the answer, write it in the comments below. And you can also come to onmaths.com or click the link in the description where you can access all of our A-level papers and predictions for free. You can even save your scores with a free account. This video is part of a larger A-level course you can follow along with at onmaths.com.